following video clip is designed to show how to properly weigh, mix, and degas the TP4051 system. The equipment required is very important for the safety of the user and to ensure our products are used properly, such as gloves, safety glasses, and a well-ventilated room are essential for use with polyurethane systems. Before getting started, it's also advised to explore the material data sheet to find important information. You'll find the name of the product, a brief description on the top, and you'll also find mix ratio, gel time, viscosity, demold times, as well as cure properties to determine if the product fits your needs. Contained on page 2 is important processing information as well as kit weights. In many cases, RTV silicone is utilized for the mold media. We will also be doing this today. The first step is to tear out or zero the scales. The side-labeled hardener is then added to the cup. It's important to ensure you determine the proper amount is added to the mix vessel. A nice approach used is to add the higher viscosity component first, so if too much is added to the cup, material can be removed easily before the lower viscosity component is added, in this case, the side-labeled resin. The next step is to add the lower viscosity portion. Care must be taken in this step to ensure too much material is not added, as the second component can't be removed if this happens. If one adds too much during this step, more of the first component must be added. The second approach is to pre-weigh the second component, taking 2 to 3 grams retane into account when dumping into the hardener. It's also very important caps are securely fitted back on the containers to prevent moisture contamination. The material is then thoroughly mixed using a hand mix method. This important step includes scraping the sidewalls, mixing the bottom of the cup, and scraping your mixing utensil into the cup. We recommend a 60-second mix time to accurately blend the two components together. Vacuum degassing can also be crucial depending on your material choice. During this step, the mixing vessel is placed into the vac chamber with the lid securely placed on top. The vac pump is then turned on and air evacuated from the vacuum vessel. It is required that 28 to 30 inches of mercury be attained on the vacuum to remove the mixed air. The air bubbles that were created during the mix step will now rise in the mixing cup, the surface tension will break, and the material will fall to its original volume. This can slightly vary depending on the viscosity of the product. It is then recommended the mix cup remain under vacuum for 30 to 60 seconds or until all the bubbles have been removed from the mix. It's also important to note that in some materials, bubbles will continue to surface, but in most cases, 60 seconds after it falls is sufficient to remove mixed air. With water clears, 2 to 3 minutes could be utilized before removal. Once the material is ready for removal, release vacuum slowly from the vessel, which will help to avoid a splattering effect. While the vacuum is being released, it is now safe to turn off your vacuum pump. Remove the mixed and degassed material from the chamber for pouring into the mold. It is important in this step to pour slowly down a sidewall to avoid frothing bubbles back into your mix. Some molds will require an extra step to remove air bubbles during the pouring process. If there are undercuts present in your mold where an air bubble will be trapped, a couple methods could be utilized to remove them. One method is vacuum casting. To accomplish this, the material is poured but not filled to the top of the mold. This will accommodate the slightly increase in volume after it is placed back in vacuum. Place the mold into the vac chamber, secure the lid, and draw the vacuum to 28 to 30 inches of mercury. Watch the surface of the product for the trapped bubbles to flow to the top and burst. Then slowly release the vacuum, turn off the pump, and remove the vacuum. Fill the remainder of the mold again, pouring down the sidewalls until it is full. Some applications require complete bubble-free castings. To ensure all bubbles are removed, the material is vacuum degassed to remove mixed air, poured into a silicone mold, and then pressurized to 60 psi to compress any bubble that might be remaining in the mix. Depending on material used, the mass of the part, and the temperature of the tool, demold times can vary. The following clip demonstrates the removal of TP4051 parts in a 1-hour window. Thank you for taking the time to watch this video. If you have more questions about processing our urethanes or specific applications, please feel free to contact us.